Imagine a world where robots learn kung fu by watching YouTube, your thoughts can control computers, and the energy powering our planet comes straight from a man-made sun. Welcome to 2025, a year where science fiction isn't fiction anymore. Today we explore 5 insane technologies being built right now that are rewriting the rules of what's possible. First up, humanoid robots achieving autonomous intelligence. On October 7, 2025, Tesla unveiled Optimus Gen 3, a humanoid that learns tasks simply by watching humans and online videos. No programming, no teleoperation. It performs complex sequences, from cooking meals to martial arts moves, with fluid motion and precision. Figure AI's Figure 03 and Agility Robotics Digit are already handling warehouse logistics, pick-assist tasks, and repetitive manufacturing duties. Tesla plans to produce 5,000 units by the end of 2025, with long-term revenue potential projected in the tens of trillions. Humanoid robotics has officially crossed the threshold from demonstration to real-world deployment, powered by advanced AI, sensors, and scalable manufacturing. Next, brain-computer interfaces connecting minds to machines. Neuralink has implanted devices in paralyzed patients, letting them control phones, computers, and robotic arms purely with thought. Every implant works successfully, with no negative side effects. The surgical robot R1 threads electrodes into the brain like a sewing machine, and future upgrades promise hundreds of thousands of channels accessing motor, sensory, and visual regions. This isn't science fiction. It's happening now, and it could redefine what the human mind is capable of. Then comes nuclear fusion power, the energy of the sun brought to Earth. For decades, fusion was 30 years away. But in 2025, facilities in China and France sustained fusion reactions for over 15 minutes, producing more energy than they consumed. Commonwealth Fusion Systems is building its Spark test reactor in Massachusetts, aiming for commercial net energy gain by 2027. With high-temperature superconducting magnets containing superheated plasma, fusion promises virtually limitless clean energy. 1 ton of deuterium, the fuel, holds the energy equivalent of 29 billion tons of coal. Google DeepMind is even helping optimize reactor control systems using AI, accelerating the path to practical fusion. Next, solid-state batteries are set to revolutionize electric vehicles. QuantumScape and Volkswagen demonstrated anode-free solid-state batteries powering a Ducati V21L motorcycle, delivering 844 watt-hours per liter energy density, 12-minute fast charging, and extreme performance under high stress. No flammable liquid electrolytes, dramatically longer ranges, and unprecedented safety, all in a single pack. Toyota and Sumitomo are racing to mass-produce durable solid-state batteries by 2027 to 2028, potentially reshaping EV adoption globally. With these batteries, a 1,200-kilometer range EV with 10-minute charging could soon be reality. Finally, AI agents are becoming autonomous software engineers. Devin AI, developed by Cognition Labs, can independently design, code, test, and deploy software projects. It doesn't just assist, it acts as a team member, handling legacy code migration, building features, and debugging complex systems. Beyond software, AI agents are transforming agriculture, operating vertical farms with autonomous climate, irrigation, and lighting management, boosting yields while conserving water. What makes 2025 extraordinary isn't just these breakthroughs individually, it's their convergence. Robots powered by AI, brain-computer interfaces, fusion energy, next-gen batteries, and autonomous software agents are all moving from labs to real-world deployment. Science fiction isn't coming, it's here. The convergence of these technologies is creating a feedback loop of innovation. AI-powered humanoid robots can be paired with next-generation batteries to operate continuously in factories, warehouses, and even homes, reducing human workload while increasing efficiency. Brain-computer interfaces open the door for humans to directly control machines, potentially merging cognitive capabilities with robotic precision. Imagine a surgeon performing complex procedures remotely, guiding a humanoid robot with thought alone, or a technician monitoring multiple industrial robots simultaneously from anywhere in the world. Energy breakthroughs amplify this progress. Fusion reactors promise virtually limitless clean electricity, powering entire cities and fueling AI-driven systems without the environmental cost of fossil fuels. The combination of fusion power and solid-state batteries creates a sustainable ecosystem for everything from autonomous transportation to smart factories, enabling 24/7 operation with minimal downtime. Meanwhile, AI agents are no longer confined to software development. They're designing, simulating, and optimizing entire systems across industries. In agriculture, these agents analyze real-time data, predict crop growth, and adjust environmental parameters dynamically, increasing efficiency and yields while cutting waste. In logistics, AI agents plan supply chains autonomously, adjusting routes, inventory, and production schedules on the fly. Every sector is becoming a playground for AI-enabled optimization. This isn't incremental change, it's systemic disruption. The technologies are not isolated, they feed into each other, accelerating adoption and capability. Investors are pouring billions into integrated solutions, startups are scaling globally, and regulatory frameworks are racing to keep pace with innovation. By the end of 2025, what was once possible someday is now demonstrably real. The boundaries between human capability and machine performance are blurring. Science fiction, long relegated to imagination, is now engineering reality, and the next decade promises innovations that will reshape every aspect of society, from work and health to energy, transportation, and beyond. Humanity stands at the threshold of a new era where technology doesn't just support life, it expands what life itself can achieve. The implications of this convergence extend far beyond individual industries. They redefine what is possible for humanity. Humanoid robots, no longer limited to repetitive tasks, can now assist in disaster zones, navigate dangerous environments, and perform high-precision operations that previously required human intuition. Coupled with AI agents, these robots can learn and adapt on the fly, tackling challenges too complex or dangerous for humans. Imagine search and rescue missions in earthquake-hit cities, where autonomous robots coordinate in real time, mapping debris, locating survivors, and delivering aid with surgical precision. Meanwhile, brain-computer interfaces are beginning to blur the line between thought and action. Beyond helping individuals with paralysis regain mobility, they could revolutionize communication, education, and creativity. Students could download knowledge faster, artists could craft digital experiences directly from imagination, and engineers could prototype inventions through mental modeling. When paired with AI-driven simulation environments, human cognition could scale exponentially, allowing collaboration between minds and machines at speeds never before achievable. Energy and mobility advancements accelerate the impact further. Fusion power promises cities with abundant clean energy, while solid-state batteries make electric vehicles more efficient, longer range, and safer than ever. The synergy is clear. AI-driven robots and autonomous systems can now operate without constraints imposed by traditional energy limits, enabling continuous operation in factories, hospitals, farms, and even space habitats. Agriculture, healthcare, logistics, and manufacturing are all being rewritten. Vertical farms operated by AI agents optimize every variable, from light spectra to nutrient delivery, producing higher yields with far less waste. Hospitals integrate humanoid robots for patient care, surgical assistance, and logistics, freeing medical professionals to focus on complex decision-making. Supply chains adjust in real time, reducing costs and increasing resilience. In short, 2025 is more than a turning point. It's the dawn of an era where AI, robotics, energy, and biotechnology are not just tools, but extensions of human capability. The world is rapidly transforming into a landscape where imagination is the only limit. The true power of 2025's technological breakthroughs lies not in isolated feats, but in their interplay. Autonomous humanoid robots, equipped with AI agents like Devin, don't just execute instructions. They learn, optimize, and innovate alongside humans. In hospitals, these robots assist surgeons during intricate procedures while simultaneously analyzing patient data in real time to anticipate complications. In factories, they adapt workflows on the fly, minimizing waste and maximizing output without human intervention. Fusion power and solid-state batteries form the backbone of this transformation, providing clean, abundant, and reliable energy for continuous operations. Imagine sprawling industrial complexes, autonomous farms, and even vertical cities powered almost entirely by fusion reactors, with energy storage handled by solid-state systems that charge in minutes and last for decades. Energy scarcity, the historical bottleneck of human development, could become a relic of the past, enabling innovation to accelerate without limit. Meanwhile, brain-computer interfaces elevate human potential to unprecedented levels. Creative collaboration no longer requires physical presence. Engineers in one continent can work simultaneously with designers halfway around the world, their thoughts seamlessly integrated into AI-enhanced systems. Knowledge transfer, skill acquisition, and real-time problem-solving accelerate exponentially. Education, research, and innovation enter a new paradigm, where learning is immersive, immediate, and boundless. Even food security, a challenge that has plagued humanity for centuries, is being rewritten. AI-driven vertical farms and precision agriculture produce more nutritious crops with minimal resources, while robots handle planting, harvesting, and processing. Entire ecosystems of production, distribution, and logistics are automated, resilient, and self-correcting, dramatically reducing waste and environmental impact. As these technologies converge, society is poised for transformation at a scale previously imagined only in science fiction. Jobs evolve, economies restructure, and human creativity finds new arenas for expression. The future is no longer distant, it is arriving at the speed of integration, and 2025 marks the year when imagination, intelligence, and engineering converge to redefine reality itself. This is more than progress. It is a rebirth of possibility. Humanity is no longer constrained by the limitations of biology, energy scarcity, or conventional machinery. The world is awakening to a future where technology amplifies human potential, reshaping the very fabric of daily life.
These technologies are incredible, but one technology outperforms all of these. If you're curious enough to know, you can click on the left side of the screen to know more about it. Thanks for watching.